basically we're asked to simplify on these polynomials. Polynomial basically has separation of terms by the plus and minus sign, and nothing strange really going on with the exponents. So the strategy here is going to be to group like terms together, and then once we group our like terms together, we combine like terms and we'll simplify. And then they like us to order it, and usually the order goes in like a descending order of the powers. So the greatest power comes first, and then it goes all the way down to the constant, which has power 0. So let's just jump right into it. I like to underline things that I start grouping together. We got a plus sign, so these parentheses aren't affecting us at all. First, I'll go ahead and group the y cubes together. So I got a negative 2y cubed. Switch out this marker. And I got another negative 2y cubed. Those are the y cubes there. Then it looks like I have the 5yz plus 5yz. That's that one. Minus 6yz. That's that one. And then lastly, I have a z squared. So that's a plus z squared. And we got a plus 5 at the end. It's important to note that these are not common terms. They're just kind of at the end. I still like underlining things that kind of go together. That just helps me kind of pair them up. And then like I said, these are separate. So negative 2y cubes minus 2y cubes is negative 4y cubes. And 5yz's minus 6yz's, one minus sign means we're subtracting with one left. We have one yz left. And then the z squared plus 5. Nothing else can be combined. And there's a little bit of flexibility with the order, but this is kind of a power of 2 right here. We think of that as y first, z to the first. So we kind of look at them together. That's like kind of a squared idea with them together. So these two are kind of comparable, and this is to some power to the 0. So we don't have to worry about it. We are done. Everything is different kind of terms, so nothing else can be combined. Next one. We got the n's and the w's combining here. So we add m plus w. Remember, addition doesn't change anything for our problem, so basically I can just jump right in and add them together. But let's go ahead and just write it out for what it would look like. We got 5w to the 4th minus 7w squared, z squared minus 3z to the 4th. I'm adding it to the n, which is, I'm going to get rid of that plus sign, because a plus and a minus make a minus, so I'm just going to put minus there. That's that. Minus w to the 4th plus 13w squared z squared minus 4z to the 4th. Once again, I'll underline things that kind of go together. So I'll use this blue again. W fourths. I got a 5w4 and a negative w4. So I'll just group them together. 5w4s minus w4, they just go together. The next one, I'll just go in order here. So it'd be this minus zw squared z squared. It has to match exactly with these letters and exponents. There's w squared and z squared, so that can go together. Plus 13w squared z squared. So I just took care of that minus 7 and that plus 13. Next in order, I got a minus 3z to the 4th and a minus 4z to the 4th. So those two got taken care of. Notice how the underlining really makes sure that we don't lose something. It's very common to kind of get lost in all these and make sure that we don't miss anything. So these go together. Switch back to black. That would be 5w4s minus 1w4 is 4w to the 4th. Negative 7w squared z squared plus 13w squared z squared. These combine, and that would be 6 of them in the positive. There's more positives. 6 w squared z. And these combine also, so those are done. These combine, that's negative 3z and negative 4z to the fourths. So that is minus 7z to the fourth. On the last one here, let's see, just want to make sure everything looks good. Yes. All right. On the last one here, we have the negative sign floating around now. So this negative is going to distribute to each term of the parenthesis that it's applied to. So there's 3 terms inside this parenthesis with that negative outside. So that negative basically distributes to each one of those terms. So I'll just go ahead and rewrite it. On the left, doesn't change. 9y squared minus 4y minus 6. And then it's basically a sign change is what's happening here. So that negative 3 turns into a plus 3y squared minus 6y minus 2. And I think on this problem set they're looking for errors. So a good strategy to look for errors is kind of to do it yourself. It's real easy to kind of get lost in their mistakes and you don't realize it. But when you do it yourself, it's a little easier to find mistakes when something doesn't link together. So I'm just going to go ahead and solve this. Same style. I'll do the y squareds. That's the biggest exponent here. So I got 9y squared. Are there any more? Yep. Plus 3y squared. And then the next one are the y's. Minus 4y. That's that one. Minus 6y. That's that one. And I got a negative 6. Minus 6 and a minus 2 right there. All right, putting these together, this one, 9 and 3 make 12y squareds. Negative 4 and negative 6y make minus 10y. And negative 6 and minus 2 make negative 8. And everything looks good on that one too.